This section we're going to learn how to find the difference quotient of a function. So what is the difference quotient of a function? It's defined by find f of x plus h minus f of x and this difference divided by h. So what it means, difference quotient is a measure of average rate of change of the function over the interval h. Okay, so if you look at the numerator, this is a function, right? Evaluate function when x equals x plus h. And then this is evaluate function f of x, and then find the difference between the two and then over the interval h. Okay, so that's why we say the difference quotient is a measure of the average rate of change of the function. So now let's look at some example. Okay, how can we find difference quotient of a function? So we have 3 examples here. We're going to do one by one. Okay, so let's look at A. A f of x equals 2x squared minus 3x. Okay, so we would like to find f of x plus h minus f of x and then divided by h. Okay, so what is f of x plus h? That's 2x squared minus 3x, right? Replace x by x plus h. So this is f of x plus h. Okay, we got this part done now. This represents f of x plus h. And then minus f of x, which is put definition f of x in the parentheses because minus f of x. And then divided by h. Okay, we just plug it in. Now we simplify. So simplify the perfect square first. F plus h, x plus h squared, that equals x squared plus 2xh plus h squared. Okay, perfect square. You can use perfect square formula to find this trinomial. And then minus distributive property, right? 3x minus 3h. Be careful about the sign. Okay, negative 3 distributed in. So both this symbol is negative. And then eliminate this parenthesis. That's a minus 2x squared and a minus negative plus 3x. Okay, be careful about this symbol. That's numerator, and then denominator divided by h, right? So we have one more parenthesis. We need to eliminate, multiply by 2, right, every term. So that's 2x squared plus 2xh, 4xh, sorry, plus 2h squared, and then minus 3x minus 3h minus 2x squared plus 3x, right? That's numerator, and then denominator is still divided by h. So now you can see on the numerator, there are 2 terms cancel out, okay? 2x squared minus 2x squared, this one cancel out. And then minus 3x plus 3x, this term cancel out. So now numerator, we only have 3 terms actually. We have 4xh minus 2 plus 2h squared minus 3h divided by h. Since numerator, every term have a h, right? We can cancel one h out. Right? Every term needs to divide by h, not just one term. So that's 4x plus 2h minus 3. Okay, 4x plus 2h minus 3. That is the A. Okay, B, I'm going to write here. B, we want to evaluate f of x plus h minus f of x divided by h, right? So that's 4 over x, replace x by x plus h, right? This is the first term, we already done. And then minus f of x, just plug in 4 over x, right? That's by definition. And then divided by h. So divided by h, we can consider that's 1 over h multiplied, right? The remaining thing. So now we have denominator x plus h. We have denominator x. So we want to find the least common denominator, which is x times x plus h. Okay, so the first term, since denominator multiplied by x, numerator also need to multiply x, right? If you cancel x out, we go back to original term. And then second term, 4 over x, now denominator we multiply by x plus h, so numerator also multiply by x plus h. Okay, the reason why we do that is because we want to have the same denominator, so we can combine the two numerators together. All right, so that's equals, still we have 1 over h in the front, and then multiply by, now we have same denominator, x times x plus h, right? And the numerator we can combine, that's 4x minus 4 times x plus h. And then 4 times x plus h, we can eliminate parentheses. So we got still 1 over h times numerator, that's 4x minus 4x minus 4h, right? That's numerator. Denominator still x times x plus h. So now you can see 4x minus 4x cancel out. So numerator will have negative 4h, right? Numerator h, denominator h, we can cancel out. So numerator only have negative 4. Denominator will have x times x plus h. So negative sign, you put on the numerator or denominator or in the middle, doesn't matter. But as the final result, normally we put a negative sign in the middle. All right, that's the B. C part, I don't have a space in this page, so let me move to the next one. Yeah, this is actually how the book do it. Okay, I'm gonna show you the process also. We want to evaluate f of x plus h minus f of x divided by h, right? The function is square root of x. So numerator, we have square root of x, right? I put in the parentheses, leave it blank. So replace x by x plus h, right? And then that's this part. F of x, just square root of x. And then denominator, just h. Now we would like to rationalize the numerator. Okay, rationalize means we want to get rid of the radical symbol from numerator. So what can we do? We know the two conjugates multiply, right? A plus b times a minus b equals a squared minus b squared, right? So in this way, square root, when we square it, and then we can get rid of the roots. So that's why we want to multiply the conjugates of the numerator, which is this is what we have right now, right? We want to multiply conjugates of the numerator, which is square root of x plus h plus square root of x. Okay, but we can't change the problem. That's why denominator will multiply the same thing. And then now numerator, that's a squared, right? This 2 squared times b squared. So numerator is x plus h, and then the second term, that's minus x. Denominator is still h times square root of x of h plus square root of x. It's too small, you can see. All right, I move to the top over here, okay? So numerator, okay, I write it again. Numerator, we have x plus h minus x. Denominator, we have h times square root of x plus h minus plus square root of x, sorry. So numerator, x and x cancel. That's why we only have h, right? Denominator, we have h times square root of x plus h plus square root of x. So now h and h also cancel out. That's why the final answer, numerator just 1, denominator is square root of x plus h plus square root of x. All right. So that's the difference quotient of a function.